Welcome to our SEAM studio here in the heart of the Free State in Bloemfontein. This channel serves to bring you only the best in aviation safety. Join me now as we cross over to one of our aviation experts, Charlie Marais.
I'd welcome everybody to the fourth delivery of 5 on the subject of stalling. And in this presentation, we very specifically is going to look at stall recognition and stall recovery. Don't go away. And now we have to look at the lift formula just once again. Lift equals coefficient of lift half rho v squared s. And now we're comparing it with the angle of attack and the coefficient of lift. And this is where the important one comes in. So let me just orientate you. We've got the relative airflow, which goes in here, the chord line, angle of attack. All right, and there we've got the wing surface. All right, so if we now go to the next slide, we will see that, let me just take that one out there and give me a little bit of a pen. All right, I started off with 4 degrees. And I said at 4 degrees, and that's the angle of attack. Now, don't confuse this now. The best lift-drag ratio happens at 4 degrees. It so happens that your aircraft, or most aircraft, if the wing is so designed, will have an angle of incidence. That is the angle on which the wing is attached to the longitudinal axis. It's got like a 4 degrees. So when it's flying at the optimum angle of attack, the best lift-drag ratio of 4 degrees, then the longitudinal axis, it won't fly. There will be less profile drag, because you're not going to fly like this. You're going to fly nicely, and the frontal area of the aircraft is going to be less. All right. So, but we'll get to that one also a little bit later. Just a comparison here. If we now go and we're looking at the cruising speed, I worked it now from the cruising speed to the stalling speed. As a coefficient of lift increases, the speed. Now remember this is to maintain straight in level. Lift equals weight. All right, just a little bit of a recap. 4 degrees, 7, 10, 11, then I just took it as a stalling at 16 degrees. But here you can see how it goes up, and here you can see how this is going up in angle of attack. All right, so let's have a look at the stalling speed, the speed where CL reaches max, that is that point, the speed where this happens. In other words, the critical angle, that is then the basic stalling speed. And obviously I say the speed is influenced by configuration, loading of the wings, and. So be careful when you start comparing apples with apples. You've heard that one before. Now, how do we recognize the stall? Well, here's the symptoms of the approaching stall. I'll just quickly run high nose, low speed, sloppy control, stall warning, maybe a little bit of buffeting. Then there could be a pitching down movement or shaking with each other and a possible wing drop. All right, if you're going to write your aerodynamics, they're not going to ask you all these. The first one is just high nose, low speed, sloppy controls, stall warning, and buffeting. That is the indications. And those are the ones that must make us aware. So, you've heard to say that attitude, is related to speed. That is when the power is a constant. If the power is a constant and you start lifting the nose, you're going to increase the climbing angle and eventually the angle of attack, and the speed is going to come down. All right? So then you look inside and you see, the speed is quite low. And if you then look at, amongst others, because the equivalent airspeed square is important when it comes to the control effectivity. In this case, you will find a little bit of sloppy. It's like she's not responding as easy. When you're distracted, difficult one in the beginning, but you'll see you'll need big corrections if she wants to deviate. Stall warning, only if it's fitted. All right, buffeting. All right, so normally with your high wing, there is a downdraft or there is a downflow. Induced flow behind the wing, and that comes here, and that will shake the tail a little bit. Some aircraft you just don't feel it. All right, So, but at the stall, there's normally a little bit of a nose pitch down. But let's just get this thing right. If you've been pulling back on the stick, bang, 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 low speed, high nose, low speed, sloppy controls, beep, the hooter, and if it's fitted, if it's not fitted, then there's going to be nothing. And then the next moment, there's going to be maybe a buffet, and the next moment, the aircraft will judder a little bit, the nose will drop slightly. If you retain the back pressure, the aircraft will do like a porpoise. That is if it's not going to flick out to a side. But this is what it can do. You know, and some of the aircraft, when we keep it in the store like that, like in the Seminole, 1,800 feet per minute rate of descent. Interesting stuff. All right, so be careful of that. You need height. You need to understand what you're busy doing. All right. Now, when will the stall occasions possibly occur? Well, there they are. Slow speed, high nose. Those are the two main ones, and you really got to pay attention to those. Over-rotating during takeoff. That is where, remember, the aircraft is trimmed for the landing. If you open up full power, you're going to have a lot of forward pressure to be able to stop it from over-rotating. You have got to pay attention. Where do you look? Outside. And you peep inside. Look at my eyes. I'm flying outside and I peep inside. I don't do this with my head. I'm flying outside, I see the attitude, I change the attitude, I look at the speed. I see the speed is a little bit low. I look outside, I change the attitude, I reduce it slightly. There it's right, and then I peep inside. So you look outside and you peep inside. Inside, if it takes all your attention, you're going to be in trouble. And many people have been in trouble. High nose during ballooning or hold off during pre-landing, we hear this so many times. So, you know, here you go, you balloon, and what do you do? All right, full power. Do you have to change the attitude? You've got to level the ship. You've got to unload. Yeah, but the ground is, yeah, you don't have to fly into the ground. If you can just level the ship with full power, she will slowly accelerate. And when it happens, don't go and pick up all the flaps. Fall out of the sky there. Let your instructor talk to you about that one. All right, and maybe, you know, there's a bad landing. So this is the kind of thing. We go and we sit in this attitude. And now if we do that, there's not enough time to round out and do this again. So how do you recover? And you will, I mean, we've said many times, if you've got a problem, go around. But what does it mean to go around? It means to take full power, make sure that she does not over-rotate, make sure that you can control the pitch, retrim the aircraft, and let it accelerate. For every 5 knots, 1 flap up. This is now where it's important, okay? So we're taking off, we've got full flaps, accelerated 5 knots, 1 set. 5 knots, 1 set, 5 knots, 1 set. Finally, the flaps up. All right. So this nose wheel landing, you can't imagine how many axes now, when a person sits on final approach and they fly into the ground like that, the only reason that they're flying into the ground, well, there's 2 basic reasons, but the first one is they're not looking at the ground. How can you negotiate the ground if you're looking inside? From the moment you've rounded out and you've closed your throttle, don't yank it close, slowly, and as you close it, you catch it because she wants to go and settle in. Say, and you hold her slightly back, and there she settles in. In other words, not on the nose wheel. Nose wheel landing's bad. It's normally when you're too fast and too high. Go around. Can do it again. What is that you're going to do? Am I going to think you're a better pilot? Of course not. Done that, been that, got the t-shirts and all that kind of stuff. Just stick to the rules. So during a photo shoot, tight low speed turns, and that's why many of the insurance companies don't want you to do photo shoots. During a fly past, high G maneuvers, I've talked about that on the visits, and tight turns to impress spectators. All right, why do you want to impress the spectators? because you're super cool. Let me tell you one thing, there's nothing you can do to impress me. I'll go different. There's nothing I can do to impress you. I have to apply the rules. I understand the aerodynamics. That's a science. It doesn't care about you. And that is the key. Show the respect. Stall awareness. Firstly, one must know how a stall is precipitated. We again here start with knowledge. If you haven't got the knowledge, you are a dead duck. Knowledge is the foundation where everything is built on. Yeah, but I've done it a million times. Yes, you've done it a million times. You got away with it a million times. Doesn't make you good. Knowledge. Understand. That's why we're doing this. Get the knowledge. Anticipate that during a certain maneuvers, the possibility of stall conditions will develop. Of course, if you push and pull and go crazy, then the stall speeds will change, the maneuvering stall speed. Always know the consequence of the intended maneuver. Always be on the lookout for appearance of stall symptoms. If you do not see the stall approaching, then you're going to stall. The idea is to notice that it's going to stall and get out of there before it actually stalls. Now, I say here that excellent trailing and advanced stalling, and we've already mentioned it, look, if you really need that, go and get somebody else. Now, how do we avoid the onsetting stall? The avoid of stall, fully developing attitude, which will relate to speed and power is the kind. Okay. When your attention is grabbed by your crew, passengers, or aircraft problems that you have, you cannot stop flying. You know the old story which says, aviate, navigate, communicate. Aviate means that you must continue flying the machine. All right? Navigate means to plan. Plan. What are you going to do next? Well, I'm going to land. No, it means, Charlie, that we're going to navigate from A to B. No, man, people didn't teach you right. Navigate means to get from A to B. But when you get to A from B, you must understand the condition of your aircraft and what must you do to manage the situation. That is navigate. And communicate? Talk. Say that you're in trouble. No, I don't want to be a national... No, man, come on. You're going to be on national TV anyway if you bugger this one up. So be careful. All right, at least try and level the attitude, which until will lower the load factor, therefore the angle of attack. Lower stalling speeds. Okay, simultaneous apply full power. Simultaneous. A lot of people say to me, but when? If the aircraft is flicked and is very close to the ground here, then obviously to full power just means you're going to mush into the ground. Remember, there's always a yes, but, and a if, and. As a rule, if the aircraft starts stalling, unload the aircraft and get the acceleration going. Use the potential energy that's needed. Use the throttle as required. Use height. That's your potential energy because you need that acceleration. Always pull out from a low nose position with wings level to the nearest horizon. So if we are looking at the aircraft and she sits there, now how do we recover? There's the closest horizon. So I'm going to balance and roll the wings level to the nearest horizon, and then I'm going to gently pull her out. And as I go through the horizon, I'm going to open the throttle gently. But if she stalls there, bang, full throttle, release, roll wings level, balance, and climb out. No problem. Now, normally when the stalling has occurred, what do we do now? The most important one is to reduce the load. That's it. Releasing the back brake, pushing the control forward, whatever you want to call it, that is the one that is important. The reduction of the load factor will immediately lower the stalling speed. In other words, you maintain control. Lowers the angle of attack. You start looking after CL max, which is now changed, and you will allow the speed to stay a constant at least, or to increase. But you can't let the speed decrease. Okay. Any full power apply full power immediately unless the aircraft has been flicked upside down. We talked about this now. When the nose is blown around, always first balance, roll the wings level, and then pull out of the dive. So let's recap. To recover, it's critical to firstly unload, that we now know, which gives the reduced stalling speed, reduces the angle of attack, and gets the speed up. That's number one. If needed and where you can, trade height for speed, because the potential energy that is locked up in the height is what you can actually put in to help to recover the lift formula at this moment. Avoid flight close to stall. Just avoid it. The only time when you will get close to the stall is during landing, and it's not necessarily that you're going to stall on landing, but that is low speed handling, and you have got to do low speed handling. At another time we'll talk more about that. Over rotation is the killer. When a bad landing takes place, keep your ego in check while going around. Level the ship and full power till speed has been restored. Absolutely important. Right, so let's conclude. Stalling occurs because we do not check and adjust the attitude. We are probably, our attention is somewhere, so stay focused. Focus. Stalling is necessary in order for us to be able to land, do aerobatics and gain low speed, blah, blah, blah. So, you know, get somebody that can do stalling and can do the advanced stalling and at least grow you so that you know what you must look out for and know how to recover if you, unfortunately, your mind slipped and now you get into a certain position. Many instructors are afraid of stalling. They do not fully understand how it works. But this, as I said, I feel sorry for them. It's not their fault. Whoever taught them. But you know, once we know that which we, if you know that you do not know, you can show your self-respect by getting to know that which you know you do not know. Okay? Do not try this at home. Okay? Good instructor. And that is very important. Well, that is the end of the fourth delivery out of the 5 for the stalling. And be good out there.
We hope you enjoyed that aviation snippet with Charlie Marais. Please make sure to visit our website www.aviationauditing.co.za. Follow us on both Facebook and Twitter and subscribe to our YouTube channel under Seams Studio.